Good evening, all. I am Professor Sarath Kumar Sahu, the coordinator of the FTP. I request Dr. Saroj Pradhan, my co-coordinator, please switch on the video, your video. So Dr. Saroj Pradhan is my co-coordinator for this FTP. So we'll start the inaugural. So I request my student, Mr. Ashutosh, to brief about the program.
Good evening, everyone. On behalf of Pala Maharaj Engineering College, it is my absolute pleasure to welcome you all to this online Atal FDP titled Mitigating Climate Change Through Sustainable Electrical Engineering Solutions. We are truly delighted to have such a distinguished audience of participants, speakers, and experts joining us from various places today. Now moving on to Atal. About Atal, the AICTE Training and Learning Academy, Atal, was established with the vision to empower faculty by enhancing their skills to achieve their core goals of higher education, access, equity, and quality. It promotes the development of quality technical education through various initiatives by the Government of India Ministry of Education. Atal focuses on training faculty and technicians to build their knowledge and skills, aligning with industry and global companies. Now, about PMEC. Pala Maharaj Engineering College, PMEC Berhampur, came into existence in the year 2009 as a constituent college of Biju Patna University of Technology, BPUT, Odisha. This college is one of the premier technical institute in the state and is funded by the government of Odisha. Government of Odisha has recognized this institute as a leading institute of repute and has 3 centers of excellence under plan of funding. Under the Chip to Startup program, Electronics and IT Minister Sir Ashwini Vaishnav has announced the implementation of the Ayushman Bharat scheme in Odisha, under which PMEC is also recognized as a training institute among 4 other institutes. PMEC is recognized in the band promising under the category colleges, institutes, government and government aided technical in Atal ranking of institutions on innovation achievement ARIIA 2021, a flagship program of the Ministry of Education, Government of India on 20th December 2021. Moving on to about the program, mitigating climate change through sustainable electrical engineering solution focuses on leveraging advancements in electrical engineering to reduce carbon emissions, enhance energy efficiency, and integrate renewable energy sources like solar, wind, and hydro into the grid. The program emphasizes smart grids, energy efficient systems, energy storage innovations, and EV infrastructure to promote sustainable practices. So let's start our today's program with the Saraswati Vandana. We begin the program with the Saraswati Vandana, which is a prayer to Goddess Saraswati, the Hindu deity of knowledge, wisdom, and the arts. It is recited to invoke her blessings for intellectual growth, creativity, and success in learning and academic pursuit. Let us join for the virtual Saraswati Vandana and the lightning of lamp. We are about to commence our event by lighting the lamp of knowledge and wisdom. This is a symbolic moment that signifies the dispelling of darkness and igniting of thought and enlightenment. It's our honor to invite Principal Professor C.R. Mahanti, HOD Electrical Engineering Professor B. Ponda, Professor S.K. Sahu, and Dr. Saroj Pradhan to do the virtual honors.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Sir, sorry to interrupt. Please unmute, sir.
Yes.
Without further ado, let us officially inaugurate this workshop. I now invite Dr. Sarat Kumar Sahu, FDP Coordinator, to kindly address the gathering and mark the beginning of this exciting journey.
Distinguished guests, esteemed faculty members, and honored participants, good evening to all. It is my pleasure to welcome you all to our Atal Faculty Development Program on mitigating climate change to sustainable electrical engineering solution, a significant initiative designed to foster excellence in teaching, learning, and research. As educators, you are the pillar of institutes, shaping the mind of future generations. Your dedication, expertise, and passion for teaching are the driving forces behind our student success. This program is tailored to provide you with the tools, techniques, and best practices necessary to enhance your teaching skill, stay updated on the latest developments in electrical engineering field, and cultivate innovative research and methods. Over the next 6 days, you will engage with renowned experts, share experiences with peers, and participate in interactive sessions, all designed to simulate your growth as educators and researchers. I encourage you to actively participate, ask questions, and explore new ideas. This program is a platform for collaboration, networking, and mutual learning. Before we begin, I would like to express my gratitude to AICT for accepting our proposal. Our principal, Professor C.R. Mohanty, HOD, Professor P. Panda, faculty members of electrical engineering, speakers, and facilitators for making this program a reality. Let us embark on this enriching journey together with the shared goal of advancing academic excellence and making a lasting impact on our students' life. Thank you. Would you please go to the slide? So by 6:30 sharp will start. The speaker is almost ready. Just now I contacted. So these are the criteria for getting the certification for this hotel FDP. So in the last date, that is Saturday, 25th January, we'll conduct one test, online test in Google form. So there will be 30 questions for 30 minutes. So everyone has to attend that. That is compulsory. Until unless you are not attending, you will not get your certificate. And the certificate will be given from the hotel website itself. And the attendance, we are maintaining 80%, and the score should be 70% mark in that test. And feedback is also must. So the test, attending 80% attendance, and the feedback. Once all these three criteria are fulfilling, then you will get the certificate from hotel. So we'll update all these things in hotel website. After that, you can download the certificate from that hotel website itself. So we'll wait for another 2 minutes. After that, our first session will start. Okay. So our first speaker is Dr. Ranjan Kumar Behera. So he will be joining soon. We'll wait for some time. At this time, if you have any concerns, you can discuss with me. We have 3-4 minutes more. And for the test, questions will come from all the sessions. Okay, from each session, around 2 to 3 questions will come. So I request all the participants, please sincerely attend all the sessions. And there are no changes in the speakers. So whatever speaker we have approached, everyone has agreed to share with us. And only one title, Professor Akhtar Kalam from Australia, he asked to change the title. That is only livable cities will be the title.
Yes.
सर आरंभ करून दो सर.
हाँ sir. Sir, can you switch on your video, sir?
ମୁଁ ତ ଜଷ୍ଟ ଘରେ ପହଞ୍ଚିଲି ଏଇଠି 2 ମିନିଟରେ ଉପରୁ ପଳେଇତ.
Okay, sir. हाँ sir.
ଗୋଟେ 2 ମିନିଟ ମତେ ଦିଅନ୍ତୁ ମୁଁ ଉପରୁ ପଳେଇବି.
Okay, sir. No problem.
ଯାଇକି. Sir, sorry. CD. Sir,
सर नमस्ते सर नमस्ते
कौन चले चली सेवन इनॉग्रेशन लेट कर दिले
okay so you had another talk in Bhubaneswar I think in Dream University today
हाँ
okay sir no problem sir we will start the session sir can you share your PPT
okay I'm doing.
because we have to allow from our screen yeah
हाँ 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 को हाँ नहीं पढ़े जाए तुम्हें
sir you can open your PPT and share screen down there will be share one icon sir you have to unmute please unmute yourself yes now it's fine
host can share the PPTs.
yes down there will be icon share
हाँ सर दूसरा I do नहीं शेयर तो हो सर
sir in Zoom download share like I told you green icon
ଆପଣ ପଠେଇବି PPT ଟା
okay sir हम से कौन আছে
ନହେଲେ ଆପଣ ମତେ କୋ ହୋଷ୍ଟ କରନ୍ତୁ ହେଇଯିବ
cost time already yes sir now you are host
Okay. Sir,
yes sir now it is visible you can expand yeah this fine sir so sir we'll go for a brief introduction okay so sir good evening again I request my student Mr. Asutosh to brief about sir okay
About Dr. Ranjan Kumar Behera. Dr. Ranjan Kumar Behera received the Bachelor of Engineering degree in Electrical Engineering from the Regional Engineering College, now NIT Rourkela, India, and the MTech and PhD degrees from Indian Institute of Technology, Kanpur, India in 1998, 2003 and 2009 respectively. He worked at Hindustan Aeronautic Limited, Sunavida, India as trainee engineer. Since May 2009, he is a faculty member in the Department of Electrical Engineering at IIT Patna, where he became head of the department in January to March 2019. During July 2008 to February 2009, he was asked a visiting scholar in the Energy System Research Center, Technology University, USA, and also as a visiting research collaborator at ECE Department, University of Pretoria, South Africa. During July 2016, he got several national and international awards such as Young Scientist Award in Engineering Science from DST, Government of India 2001, selected as the featured Engineer of the Globe 2015, USA and Bhaskara Advanced Scholar Energy Base Award, Indo-US Science and Technology Forum 2014 for doing solar research in Energy System Research Center, Tanis Technology University, USA. Included in the world's top 2% scientists for year 2022 and 2023, and list is compiled annually by Stanford University. He received Outstanding Paper Award for the IEEE transactions on industrial electronics for year 2022, held in Brussels, Belgium, and received a cash prize of $3,000. He published 134 research articles in different national international journals and conference proceedings. His current research interests include power electronics, motor design for EV, high power motor drives, smart grid, and IoT applications. He delivered more than 200 technical and 420 motivational lectures in India and around the globe. He is co-authored a book entitled Power Electronics, Drives and Advanced Applications, CRC Press, April 2020, and edited a book, Applied Artificial Intelligence to Green Power Technology, Nova Science Publishers, November 2022.
Over to you, sir, now. You can
Thank
start.
you so much.
Thank you, sir.
I am in front of sir, I am a student. Well, just he requested me to give a talk, so I am giving this talk. So today I'll speak about advanced power converter and grid control integrated solar and wind. But we'll try how much we can finish. Maybe till what time, sir?
8 p.m., sir. 1.5 hours.
8. Okay. So we'll try whatever things, but I'll tell few very interesting projects which have implemented in different places around the world and in India. So that I'll discuss in the end of this lecture. So already this is already told by him. Mainly my research interests are power electronics, wireless power transfer, EV design, smart grid, or other applications. And then we do many, nowadays we are working on more on electric motors for EVs actually. So we developed many kind of motors. So now also we got a project from DRDO which to make a permanent magnet motor for the high-speed jet engine. So which they have given just last week only they sanctioned around 1.2 crore rupees for development of integrated controller with motor. So these are the different technology which we develop, we display also everywhere, and this is my research team now old, and we also sometimes develop this electric vehicle, 2-3 technology we have developed and also displayed. For this we got around 5 crore rupees for development of the company. So then there are 3-wheelers also, which is sponsored by NAMPET. You can see that we developed a 3-phase induction motor, which is 5 HP, 110 volt or 80 hertz. This motor is designed special for Indian roads. And these are the different products which we develop. And you can see that Mr. Kumar also came to see his, is given a project for smart irrigation system. So we developed here and here are these books. And if you see, these are the, today we will discuss about this very basic of how controlling and modeling design of a grid connected current source inverter fed the PV system. So this current fed, you will see, generally PV system is integrated with the grid with voltage source inverters. They hardly you will find current source inverters in anywhere, but the current source inverter, it actually protects from the reverse power. which is the most important factor till today in our power system. We are facing the problem of the reverse power flow. So this is the current source inverter is feeding to a grid, and grid is connected with a filter circuit and from the PV. So designing this current source inverter, then controlling it is really challenging, because if you see in the solar inverter, there are 3 frequency component counts, which hardly nobody do any research on that. But if these 3 frequency component can be properly managed and designed, then the complete your inverter system, you can understand the fundamental behind the inverter connecting to the grid. So what are these components? One is switching frequency of the inverter. Second one is your resonant frequency due to filter. And the third one is your sampling frequency due to your controller. So this controller, I told one of my students, Jitendra, who developed this very, very nice controller. And I asked that how to develop a match between your resonant frequency and your grid frequency. That study he has done, and few papers are also there. You all can go. Then this is the control structure of the this one. So, and then this is the mathematical model. So I don't want to go in the detail of mathematics, but you can go into see our papers where all these mathematical formulations are given here. So if you see a simple plant model, it look like this. It's just a simple KVL equation. You can write down all these sign are not somewhere missing. Okay, anyway. So this is our plant model. And this is our controller. When we design the controller based on the phase margin and gain margin, you can understand whether your controller is tuned properly and it is stable or not. So by seeing this, if you see, there are few constraints in current source inverter. Because current source inverter, always 2 switches should be turned on. If one switch will be off, or if the 2 switches are not on, then all the switches they may damage due to the stress on the device. And second one, when the more than 2 switches are turned on, then you may get sometime the harmonic undesirable characteristics harmonic. So when you get like that, then you cannot properly design your filter or the circuit. So you can see here the CSI, the active switches and null switches, always there are 2 switches are on by which there is a proper circulation of the current, constant current sources. So that is what the PWM scheme of the CSI we have found out. Then in the voltage source inverter, we generally give DC-link voltage as a reference, but in case of this, we give a DC-link current as a reference current. So if you see here, this one, the exact current is tracking that one. And second one, both the grid voltage and current, they both are in phase, in the same phase, by which both operate at unity power factor. And that means you can see that unity power factor operation means we are operating at maximum power transfer capability. Second one, there is no reactive power drawn from the grid. So this ensures the 2 conditions from the grid. There are many things you can achieve by this way, but these 2 are main cause for this. So you can see that although the MA sometimes modulation index also more than 1 also, but this is controlled very nicely. So this is the voltage VDC. Like in case of VSI, you will give the charging current structure is like this, but here the voltage structure. And these are the 3-phase currents output. And this current output, you can see that they are 120 degree phase. And they are in the phase with your voltage. And this phase, in phase voltage, they actually gives us the more efficient to the converter. And then we have to test whether your harmonic distortion should be less than 5% or not according to grid code. I'll discuss a little bit about grid code, which is very important thing for a design engineer. When you will go to a market and you go to work in any field, you'll find grid code is very important. Then these are the filter voltages, and this is the voltage of the filter, inductor, and capacitor. And this is our FFT, and this is the current. So another thing is very important thing, whether we are using a PLL just to synchronize with the grid. So I told today morning also, what is synchronization? Synchronization means to adopting a condition by which you are comfortable in that situation. For example, you go to America and you want, after going there, oh, you want rice, dal, sabji. Nobody will give. If there is a burger, there is pizzas, you have to synchronize. And once you synchronize, after some time you can buy some vegetable and make a nice khichdi or rice, whatever thing. But initially, if you go and that thing that, oh, I should get all these things, you will not get. You need to synchronize with that situation. Exactly in a grid, and this and the inverter need to be synchronized. And this PLL has an important role by which, that means you are going very, then this PLL, the track. So this is the testing of that one. So if this will not properly track this one, then your grid synchronization will have lot of difficulties in that. So if you see this one, the performance of the controller, it is you can see here, this is our three-phase this is a three-phase inverter feeding to the grid, and it is designed for 50 kVA system, and this is fed through a microprocessor called DSpace1102. So these are the few results which experimental result how the current tracking takes place. So this is the conclusion in this one. Then we will see this conventional method of transmitting power. So nowadays, if you fed your very high power solar integration or wind integration, it is very difficult. So this project was given by the Ministry of Power. And this project was given because they want to see when solar injected to our high voltage grid, what are the effects, and that one is need to be designed. So a small prototype is designed in our laboratory, and in that lab we developed a short transmission line, medium transmission line, and a long transmission line. And these are, you can do this modeling, and the students, they can easily do this. And then you are feeding those high voltage transmission line, the three type of thing. One is your solar, another one is your wind. So you see here, this one. So this when you feed this, so we have put all the smart meters also here, so that you can easily control whether you are transmitting for long transmission line, short or medium. So how you can do that based on the power. If you are generating more than, here we discussed about 5 kilowatt for long transmission line, 3 kilowatt for medium, and less than 3 kilowatt at the short transmission. So that completely is designed by using the Z parameter equivalent. Then this is the prototype of the transmission line under the renewable penetration. If you see here, these are the transmission line we developed in the laboratory. You can see here, there are parasitic capacitors. These are the capacitors. And there are also local loads, and the white one was the smart switches, and this is the completely one is designed here. And this can be done for both. You can see below are the inductors. The inductor is a line inductor.
Sir, I want to interrupt for a second.
Ha.
Sir, you are the host, so we could not control over here. The participants are joining here. You please allow them.
Oh.
Participants are on the queue.
In
waiting room. Yeah.
Yes.
I-
You can
I-
make me
admit-
co-host. I'll make you co-host.
Admit all you can press. Yes.
I think just 1 minute. Sir.
There is no co-host option. Only one host option is there. So that is why.
Make host or
Ah,
sir, once I share, you can become host. There are a lot of people joining.
you can make, huh?
I just one will I see that how we can do.
Just no, just by clicking. You got it. It's only the screen.
Mhm.
Sir, one of my student I asked you can in your settings you can make change. Sir.
Yes. In my name, you can just right, click on Professor person.
Just
Ah,
mm,
make host, make host. You can click here. Just stop, little down.
okay.
Make host.
Yes.
Yeah. Okay then. Okay. Yes. Oh, now, slide is.
Yes.
Sir, I think you are using iPad, sir, or laptop?
Yes.
iPad. You just.
Again, he's saying that only host can share.
No, sir. This is iPad, so you just drag up.
So just try sharing. It will grant us a pop-up screen. We will grant you the permission. Then you can share the screen.
You see now.
So try now.
Okay. Now it is coming.
Yes. Sir.
Yes, sir. It is coming.
It is coming. Okay. So here we have developed that complete power system. You can see the power in the transmission line with when one load connected and both the load you can have smart switches to control all those things. So this you can see that this is the power transfer, and this is this project was displayed and so got student innovation of this one. So let me put this. You can see the practical system here.
This is the transmission lines, and
This is the smart meter, this is the smart switch, and we have the three types of load. One is indicating 80 kilometer. After 80 kilometer, this is the light load, and after 160 kilometer, we are using another light load. After 80 kilometers, indicating the house type of load, and after 160 also another type of house.
I think you are able
And
to
after
hear or
240,
not.
we are connecting another load that is indicating resistive load of high rating. This is indicating as an
Is it
industrial load.
audible?
And this is on-off can be observed on the CR.
Yes, sir, it's audible.
And now we can see the rating of the transmission line. Receiving end voltage, we are applying 230 nearly 230, and we are getting the sending end voltage around 235. It is meaning the Ferrante effect is occurring on the system. Now we are going to.
So this is main about
loads.
the three-phase line,
Now
how
I am
it
just
is
calling the.
and complete
After 80
control.
kilometers, we are on the load. We can observe by the mobile only we can on off the load, and the power rating is also showing that 150 watts power is getting. Now another load is 160. After the load is also on, and we can observe the around 250 watt is total 80 kilometer, and after 160 kilometer total power is now applies to 250 watt. Now we are going to on the load 3. We can observe on the CRO now current is flowing, and the total power is 270 watts totally. Now we can control. Now we are offing the breaker 3. We can observe the rating is automatically set down to 250 watt, and the current rating also changing. Now either if you want any fault conditions will be occur, we can easily isolated with the mobile also we can observe. And now 80 kilowatt load is isolated. Now we are going to observe only 160 watt, and auto also we are going to off it.
So this is how. So this then we have developed all solar microgrid is a small endeavor that when you have a V2G or voltage, the vehicle to grid or grid to voltage transmission is very important thing. If you have a battery and this, and you want to stabilize the grid by feeding the power, you require a bidirectional converters. So this way, we have developed a bidirectional synchronous link converter by which you can feed power from the grid to the DC link voltage, from DC link voltage to the load. And sometimes, if you require, sometime during night time, your voltage is destabilizing and feedback that to the grid, that is also possible. With this, so this is we use a dual active bridge converter. And this dual active bridge converter, when you feed to the grid, you can see that there is a sinusoidal and they are in phase. Although you can see that because of the solar irradiation, this may be changing different magnitude, but still you can see that the voltages are in phase with the current are in phase with the voltages. So if you see, sometime due to the fluctuation of the power, like this power we get the DC voltage, and it also reduces the reliability of your system. And there are a few results of the current and how this voltage transfer takes place. If you see, a simple voltage transfer can be taken place in a dual active bridge converter just by your phase leg or the phase displacement. It can lead the phase to transfer power, and this is a very easier method. And now DC-DC converter, you cannot go very high voltage ratio, whereas in DAV converter you can go. And also 1 kilowatt of your transformer, you can see that converter, you make it to 50 watt transformer, it is very big inside. But if you 1 kilowatt of the dual active bridge converter based system, it is reduced nearly 1/4 of your design. So that is where there are this current, how it is transferred to this one, and this is showing that how power is flowing and what is the power flow, everything is given in this one. And second thing, when you have given reference, for example, from 100 volt to 200 volt, suddenly you want to increase, and automatically because of his closed loop control, so this is following that one. You can see that when you want to transfer the power and current in that way, you can transfer. Another one is microgrid. If we have like this microgrid, this is taken as a simple, small, you can say that this is our simple microgrid. You can say that whatever is we use. Generally, if you have a small ship boat, ship engine. So,
मतलब नहीं ही देना होता है। अभी आप इसमें मध्य का मतलब मुझे क्या पता, मुझे लगा मध्य यानी कि मध्य
so there is some this is generally designed for a ship boat. In ship engine, generally we have a solar plant and a battery and a single phase grid. I have taken this grid is equivalent to the diesel generator and feeding to a DC load, and then all this induction motor is a propeller, and also three-phase grid if you have a three-phase system and DC loads. So these are a simple DC microgrid system in a shipboard application. So when you connect one after another, there is a lot of integration problem. Like we say that we should be very easily synchronize the thing. It is not so easy actually. It is so difficult to connect to a DC to AC, again AC to DC, and controlling all parameters, whether they are matching voltage, matching frequency, their power ratings are different, and their analytical studies are different. So there are a lot of things that we need to understand before integrating this. So if you see here, these are the few results only, how the battery voltages they are changing, how the charging currents are changing, how the power input are flowing. So these are the different thing. And then if you see this one also, we try to manage that because of the synchronous link converter in the input side. So we have both voltage and current are in phase, and one is in phase, another one is out of phase. So when power is feeding back, it is out of phase, but always remain at unity power factor, which is for nothing but you are operating, drawing less, low reactive power. Reactive power exchange is very less. So if you see here, when our power is feeding and sometimes feeding back to the power to the grid, also you can see that it is very nicely within 1.5 cycle, this control is taking place. You can see that within 1.5 cycle, it is controlled. That means your grid is very well stabilized. So this is our experimental, where you can see that this is the dual converter 1 and 2. They are clubbed together, so the high frequency transformer, and this is feeding power to this load connected. Load means a battery setup, the arrays of batteries. So this way, these are the few experimental results where we got these experiments done. This is your phase delay, so that power flows from input side to outside. So to want to know more about this, these few papers are there. It is available in the IEEE transactions, so you can see. So this is a single stage grid integrated. So you can say that, sir, there are a lot of grid integrated like this we have already seen. So what is the new in this one? The new is the fundamental concept of controlling the hysteresis band based on the power quality controller as well as the local load synchronization also. So if you see here, this is there are grid following inverters, controlling the synchronization, all those things. So these are the basic MPPT algorithm we implemented. But then in this one, this PV system connecting to the grid, And these are the simple mathematical equations. So this you can read from those transactions. And this is the three-phase PV module, which is integrating with the grid. And we have a filter circuit and the grid synchronization. And these are the equations. You can mathematics, you can just modify the simple, you can write down each switch action, and then you write down the equivalent circuit. And from that equivalent circuit, you can just write down the equation. There is no component. The very simple switching function is the S function is switching function. 1 is 1. S1 upper switch is 1, lower switch is minus 1. Like that, we design the switching function. And after this, then what are the important criteria for filter design, which is a very important thing in design. For example, if your inductor is very high, then you will find that this response is very sluggish. If inductor is low, then current rushing capability will be high. When there is a fault, all the device will be burned. So low voltage ride through capability also you will not get. So you need to find out the optimal value of the inductor. And also the capacitance, if large capacitor you give, then that capacitor charging current will be very high. And low capacitor you give, filtering action will not take place. So there are a lot of challenges in designing this simple L and C. So many papers you will find the L and C definition, and that is what is actual that way. Then designing a PLL circuit for synchronization of grid connected inverter system. And when then your voltage is fluctuating, or there are voltage sensor where you are measuring, there is some error. So how to estimate that? It's a very, very challenging factor when you go to grid connector. For example, when we go for very simple way of connecting a grid, that we bring an inverter connecting into a battery and connect it. But actually that is not the solution. When practically we go, you can find a lot of that. This is one of the paper where you can read that about the just PLL, and that is very important. So if you see this one, the PLL structure is designed, and then it is the proposed method is controller design and verified by the board plot. Then we use those parameters in understanding this one and implemented in a OPALAT based system. This is our OPALAT system where we implemented the complete system in this one. And this is our voltage. If you see the diagram for error generation is a very important thing, because you generally take the, for example, once I was measuring a speed, and the speed encoder, because the shaft is vibrating, speed encoder is not giving proper result. Although I put a very picofarad capacitor for filtering action, but that filtering action was not going. And it will always, there are a lot of ripples are coming. So when we are feeding to our controller, the motor is vibrating mode, it is like an amplifier. So that, although we are doing that one, but we are not able to understand what is the cause of it. So this is what the error generation diagram is very important thing there. So then we implemented the Lyapunov function based system, where instead of PI controller, we used the Lyapunov based controller. Why? Because generally the nonlinear system, the switching systems are always nonlinear. A nonlinear system you can model in nonlinear way. And most of the time we only use the linear model, putting KP, KI, or some PID controller, something like that. But actually nonlinear system, there are a lot of limiters, hysteresis band, they cannot be modeled in linearly. That is why the describing function can be introduced to understand the complete model. And then we have, these are the result where we have how this different PLL, they really the coming error. So you can see that this frequency and phase angle error, you can see that there is a lot of, you can see there is a different kind of this PLL, like modified first order, mixed second order, third order, and then moving average filter, all pass filter. And these are all the things when you take and compare this one, and we proposed a filter which is very, very the better performance. And this way we can say that going on in different. So second scenario, when there is a voltage check, how the filters, how this PLL is taking actions, that is a very important thing. So this upper one is the simulation, and lower one is our experimental result. So you can see that the proposed filter is better, it is giving better understanding. So if you see here also, this is also the experimental result for this. So if there is a DC offset, generally DC offset comes due to integrator. If you have in controller, you have an integrator, DC offset will come. Second one, if in your control circuit, there is no grounding, or grounding is disconnected. So there will be an offset. So offset means always it gives it introduces a DC. And as soon as you introduce a DC, your filtering action, if the low pass filter will filter out those things, and high pass filter will give, it is an error signal. So integrator, sometimes people use a first order filter, one like that K by S plus 1, instead of integrator 1 by S. They put some gain also to adjust that one. Still, sometimes when you have like that also, because of this low pass filter action, the integrator, there is a lot of delay by which we get a lot of problems due to stability problems. So that is, there are a lot of things need to be understood before implementing this offset methods. And this is in drives also we get the similar kind of problem when you go for vector control, the same kind of problems arises. But here we properly we proposed a system where you can see that DC offset can be properly taken care in the frequency as well as a phase angle error. So then the grid voltage severely polluted with 0.05 parameter. So if your grid voltage is severely polluted, you can see that these are the grid voltage, the structure of this frequency. So lot of there are fluctuations, but you can see that our PLL is 50% of that one. And if you have a weak grid like Indian system, like somebody, there is a voltage sag of that one. So how to taken care of the frequency. So these are the, if you, another one is when I have gone to one place in, so they have also, they like this problem because it is a village and the voltage fluctuation is very high. So this way, this happens. So when we see the comparative result in that one, you can see that there are a lot of methods which is proposed, but the methods which we use has the better performance as compared to others in many aspects. So this is Jitendra, and he did a grid integrated. You can see here there is an isolation transformer, and he is feeding power from solar to the grid. And this now he is in the Denmark energy solutions. He is working in Denmark. So he feeding power from the grid to by single phase and with the local load also. He is feeding power. So this is he demonstrating this complete power feeding to the grid also. So you can see that the power is injected, all this you can see that this is the power index, and you can monitor in our computer also by using this one. You can see that this power is put into the grid with
Step change
388 volt, 89 volt power, the voltage at this voltage is. So this is how we implemented the complete control technology. Then there are one project which came from the SECI, the Solar Energy Institute from Gurgaon. So they wanted that, sir, actually they are testing mainly the standardizing the solar and also the solar inverter, everything. But they could not able to find out that when they connect the inverters to the grid, how the inverter malfunctions, and after 2 to 4 days, the inverter burns. So they are putting even 5 kilowatt, they put a 7 kilowatt inverter, still it is burning. So they gave us this project, to study under which condition, what are the stress, what are the thermal, and 3 study we did it. So that is what is very important system we developed here. If you see here, if you see the grid voltage is, you may be red color is sinusoidal, but the current you see, it is nearly like a triangular. So how this, you want that, you want to feed it to this sinusoidal, but current is rectangular. So what are the problems? There are a lot of power quality problems. Although we are not able to see, but it is happening, it is there, but inverter could able to suffer. For example, somebody may give you some lot of food, very poison, some food which is very pungent, and they gave it. So although you took it, but you only know your stomach pain, other thing, you only experience that one. So this is what you may be connecting a grid, that what is the problem is, you can manage. So there are a lot of standards which generally we do not look at it. First thing is the equipment and functions are necessary to compatible with people. It's not that you purchase and put it, it will work. No. That is why there are a lot of standards are there, need to be studied. There are European standard. That is that PV, there should be harmonic limitation and total harmonic limitation. Voltage harmonic also limitation is there. So those are standards we never studied, and just we go. And the total voltage harmonic up to 40th harmonic needs to be careful. So this is the simple experimental setup of 45 solar panels up to 10 kilowatt range, and there is a complete interfacing, feeding to the grid and feeding to the local. Then there is some storage and interfacing. If you see here, this is our implementing. Then we model this one by using a simple inverter circuit. Then this is, I think there are some, there is not visible, it is a matrix in state space form, and it is a current. Then we have controller design. This one is our controller design. And this we implemented. So you can see here, this is in power quality monitoring. You can see this one is your power quality monitoring. Then we have a PC, and we have used a battery of 2 volt. Why 2 volt? It's a very important thing when we understand. So you required a voltage of at least 200 volt. Why 2 volt you use? 2 volt we use because 2 volt battery, like a Tesla car we have. In Tesla car, if you see, they have each battery, each cell capacity is 2 volt. In the 2 volt, and they charge or discharge. If in a string of batteries, if one battery is discharged completely, that will not behave like a short circuit. So that will not behave like a short circuit. Why? Because that will behave like a bypass. So that is what voltage, the battery unbalance will not take place. So that is how this is the given is in this way. So so we use that one till today. Those batteries are working. Then this is, you can see that there are a lot of current harmonic and voltage and current, the simulation result. And this is our THD performance. And you can see here, the current is not a sinusoidal, it is like a distortion. In the low loading or partial setting condition, you will get like this, which nobody observes this one. And then if you perfectly load it, full grid with full loading condition, you can see both current voltage are sinusoidal. With this, if you see here, both during the inverter feeding to the grid also, they are both very nice and sinusoidal. And when if the grid is feeding to the inverter also, that time also for charging the batteries, that time also it maintains unity power factor. And this way, this whole system was designed and very nicely. Then we'll do a little bit about the wind energy conversion, which is a very important thing. And if you see here, the aerodynamical modeling and wind energy is not, we don't look at a simple an electrical engineer how it is designed, no. But I remember I have been posted in Hong Kong for a G wind, and in that one we installed nearly 50 megawatt wind turbine. So there you will not find that oh, this wind turbine is there, and that's what the wind turbines you can go and connect to. As a lead engineer, you have to look into all these things: aerodynamical modeling, mechanical system, electrical system, and you are the boss for that. And you cannot say that, no, I don't know about it. No, you have to know. So that way, the wind energy system is, there are different components of that, like turbine, gearbox, generator, power electronics. And there are a lot of power limitation, maybe down due to the stall control. And there are different kind of control. If you see a wind turbine system, these varieties of control, varieties of motor, generators, varieties of gearbox or direct drive, and varieties of turbine structures, varieties of loads are connected. So there are many, many things which is very, very important to understand this. So if you see here, there are a lot of control, like stalling control. And there you can find out what is the power limitation, at what point. Then what are the stall control? Like stalling means there is a wind, because big turbine fans are there, and beside the fins, there will be a lot of the reverse wind also. So how to take care of that one? By using stall control. And the active stall control, where you can use them, there are pitch controls. So this is the pitch control, where whenever there is a heavy wind, your blade can be turned so that wind can flow. It will not give any jerk or any unbalance to the centrifugal force of the turbine. So this way, this is our lot of wind turbines structures. Most important thing is that there are dual feed induction generator, where you have 2 feed. One is slip ring, another one feeding from the starter. But starter we are giving back, and through the magnetizing inductance we have in induction motor, which does reactive power. So that reactive power we are feeding from the rotor, and active power is really feeding from the starter. Like that, both active and reactive power independently controlled by this one. There are few generators are called the squirrel cage generators, and they required some external excitation like the capacitors. And there are synchronous generators which are very powerful, and these synchronous generators are feeding power. And there are also, you find that there are a lot of big turbines which is based on the permanent magnet synchronous generator up to 2 megawatt capacity. So if you see this one, that the even Boeing aircraft 113 is bigger than the Boeing 747 also. So you can see that there are very high wind power, the high wind turbines, and in Odisha also we have a lot of potential of high wind turbines, especially in the area where from the 10 kilometer from the seashore we can have such a high. So what is the important factor when you have a wind or solar? The important factor is high voltage ride through and low voltage ride through. So these two, like if you see sometime you can look into the, I think wind turbine, G wind. There is a nice video. So that one, this, for example, you are carrying a big basket of water. If somebody will come and push you, so you will become destabilized and water will fall down. Exactly, the wind turbine is supporting to the grid. And suddenly wind turbine, there is a heavy wind, which is cut in and cut out speed, which is meant for the high power wind, not low power wind. 1 kilowatt, 1.5 kilowatt. You don't think of what is the cut-in speed, what is the cut-out speed. Those are not required, pitch control not required, stall control not required, nothing is required. A simple wind turbine, house wind, you run it and get some power, use it. That's all. But when you go for this type of, for example, I remember when I was working in G, we installed around 750 kilowatt generator, wind turbine generator, and we installed, just we came down. We were taking food, we saw that the wind turbine is burning. So I thought that what happened to this burning? So then it burned after maybe 8 hours, we went there because sometimes the fire may sustain for a long time. And then we got everything on power, everything, we went to the again top to the turbine. And there I find out that in the gearbox, one of the teeth is broken. So because although we put a lot of grease, insulation, everything, but because they are turning, it is very heavy structure. So when they are rotating, when there is a slipping, the one teeth is not there, they slip during that period. And that creates a lot of fire. And that burns that one. So this is very important thing, that the low voltage and ride through and high voltage ride through is very important concept altogether. So there are different type of wind turbines. All of you know that related, but I just give an introduction just because the permanent magnet synchronous generators have been very popular, and now people are using for this. So this is the Siemens Gamesa, which is one of the world's biggest wind turbine and 10 megawatt capacity, which can supply nearly 20 villages in Australia. So this is what, and if you see that there are different kind of, so we say that where is the ride-through capability? You can see direct drive permanent magnet synchronous generator gives this one, and that is what there are a lot of size increases. That's why the gearbox, and nowadays we have also developed one gearbox that it's called the magnetic gearbox without any touch contact, no fire. So that we are developing, one of the patent also we supply for this. So anyway, this is how the 10 megawatt generator is being developed today, and these are the few companies who can produce big generators. So so that is how this generator's requirement. What are the technical requirement? So megawatt range generators, the initial cost is very high. Reliability, modularity, efficiency, grid code, and cable size and losses also very important. So that is what many people, they have given reduced the functionality, that some control switch. So this type of generators are available. and full power converter with megawatt, like 5 megawatt. In case of double fed induction generator, we have converter rating is 25% of the total rating. But here, if 5 megawatt, your converter rating also must be 5 megawatt. So this is called the topology. So similarly, some synchronous generator-based also system can be developed, and there are standards of the high power conversion. And then we have this is the wind power, this one. So there are many topologies available, and you can look into that one. So I am not going all these topologies, so I will go what we implemented. So we implemented this is the megawatt range, the wind turbine connected to the 3-level neutral point clamp converter, then DC link, and feeding to another 3-level, then feeding to the grid. And this is the direct drive. So what we have two control. One control is the generator side converter, another control is from the grid side converter. If you see, this is modeling, the modeling of these converters, and this is the current control. And this is our permanent magnet synchronous motor generator modeling. And then if you see here, you can see that when it is power is feeding to the grid, although the magnitude, because of the wind generator produces wheeled power. So your wheeled power always generate wheeled AC. So wheeled AC the generator, because the power is like you get water. So sometimes you put water in a filter and drink that water. That filtering has not done. Then it is called wild water. So similarly, this is wild power. So similarly, this you get a lot of fluctuations in this one, and but the unity power factor is maintained, and this is the 3-phase, the voltage and current waveform of this generator. And you can see that as the RPM increases in the wind turbine generator, you can see that it is simulated for 10 seconds, and whatever RPM is the speed rotating, similarly, the power also exactly following that track. That way, this is operating under the maximum power point tracking also, as well as in the wind turbine. And you can see that it is nearly 6.7 into 10 to the 4 watts at least. It is nearly 670 kilowatt or 0.6 megawatt. So this way, so what is the problem when you are feeding like that? DC link has fluctuation. And because of the fluctuation, one capacitor is charged 600, another capacitor is charged 300. In such a big grid system, the huge turbine, there is a voltage difference in these two capacitor banks will create a lot of the two problem it will create. First thing, it will create more common mode voltage. Second one, it will give reverse power flow. And third one, it will destabilize the complete. So this way we have we used a voltage balancing circuit by which within a cycle both the capacitor voltage will balance, and after that you can see that both the DC link voltages are constant and they are nearly balanced. And that is what we have tested with the low voltage drive. So when grid code is applied, when there is a fault at zero, at time of the fault. So at this point, when there is fault occur, your voltage come down. That time, your converter must be stabilized. So this way, there are few grid codes, Spanish and German grid codes. So we implemented it. After implementation, this grid code, this is our output. You can see that during voltage sag and all the conditions, the DC link voltage is stabilized. And this is our modulation index. When there is a low voltage grid, you can see that the modulation index rises. When there is a grid voltage low, M is high. So that M into VDC, your output volt power, and the output voltage stability can be maintained. This is what the conclusion. And this is the current, and you can see that when there is a voltage right through, that time also the ceiling voltage is very stable. The both VC1 and VC2 both are very stable. And this way, when there is a low voltage right through, 3-level converter is act like a 2-level, and it is a proof. If modulation index is less than 4.4, and then you will get always the 2 level. So this way, we implemented this hybrid system, and this is we built for the government of Bihar, and this we built for government of Bihar for, it is a energy kit. Whenever there is a flood or anything, it is like a small pack of energy system. You can go and take to any place you want and put it, one solar, one horizontal axis wind, one vertical axis wind. Horizontal axis wind generator used for high speed, and vertical axis at low speed. They both will work. If both are not there, this solar will. That will charge the battery. Emergency power supply can be designed, and it is tested in our that place. So you can see that it is all battery pack, everything is connected within, and it is around 400 watt current and voltage pump. Then we have few design. One design is in first design I remember we doing in Tennessee Tech University, and this completely 12 kilowatt design we did, and there are a lot of problems. No wind clearance, no optimal angle for summer, because summer winter the travel of the sun are different. No structural, no grass relay. Then this I will get a lot of insight. Then this is next one is Nashville project, and near Tennessee. This is the Schneider Electric company, and in that we need to develop the microgrid system for them, a solar microgrid. And in that we developed 1 megawatt and completely interfacing, and very nicely we developed that one, and we have the control room, and this is the solar. And then third project we did in IIT Patna itself, a 10 kilowatt solar microgrid, this microgrid, and 200 wind power clearance, all structured, everything designed by our students. And then the grounding system is one of the very important for a solar system, and this is our complete. And then 1 megawatt at IIT Patna again we developed under the when the sponsor was given from the Ministry of Energy, Renewable Energy, MNRE, they've given, and we have completely 1 megawatt installed. And this is our, so this is our, this is our unit where the 40 unit of one village, nearly 15 village we electrified, and this is sponsored by Dr. Saran. He stays in Sweden, but he gives a fund, and we went and utilized this fund for giving power to many villages. And this is one of the projects we put in Toypur with the generator, and this the complete unit of Toypur village, and 50 houses we supplied. There is a diesel generator and this both. So they both will this we put in the Toypur district, and this 1 megawatt microgrid we put in the in Port Blair station, and the problem there is the sand particles and unstable structure. So then we developed that complete unit. This is the complete design of this. This total number of the strings are 154, and these modules we developed. All these are the cabling of this complete solar system. Then these are the earthing pot. You can see that how many earthings we have given for 1 megawatt. The control room have nearly 8 earthing pot, and all solar plant in each string, in the 4 string, we have given 3 earthing pot. So complete solar design we developed in that place, and few we have developed in our laboratory. This was given by, sponsored by Ministry of Education, and they have given us imprint project of 2 crore, 2.5 crore, and we developed this whole microgrid. And this is the smart microgrid with wind, solar, and smart controller. And a few, this is the micro turbines, where in your house also you can put it, which we developed in Tennessee Tech. And this is our then this is a microgrid, and this is a small video how we developed this microgrid here.
Our project is mainly focused on software development.
So this is the
And this is the
wind
System.
turbine, and the connecting.
This is the microgrid setup and the combination of the DC-DC converters, and this is the grid tied inverter. It is directly supplied to the grid, and this will be going to see the PV.
And
This is the emulator, and we're going to see the
again,
parameters controlling
we
with
tested
the help of the
our
lab view.
Out,
We're going to get the
outside also,
PPT technique.
where we implemented this one with our
80 kilometers indicating the house.
So, okay, thank you so much. If you have any question or comment. Sir, any question or comment?
Participants, any questions?
Hello, sir. Good evening, sir. This is Kandasamy calling from Rajalakshmi Engineering College, Chennai.
Okay,
Hello.
please. Please,
sir, I just have one question. Actually, you discussed about some different types of topologies, wind energy, solar energy, and connected to the grid connected system, sir. That was very nice to listen to your lecture. I have one question, sir. What is the scope of matrix converter in grid connected system, sir?
Matrix converter actually, the problem with the matrix converter, there are a lot of problems actually. I remember in my lab also we have developed a matrix converter, and it is so complex that control became very difficult. And second thing, the filter design also very difficult. But there are a few papers, and I remember in our lab, one boy, his name, he developed a matrix converter. We were feeding 10 volt, but in output we were getting nearly 500 volt. So I was very confused that how it is coming like that. And at last he could not able to finish his PhD. At Kanpur. But matrix converter, people want to use that one, but there are a lot of limitations. Because of the control problem, and second one, the switches. A lot of switches they burnt during the experiment itself. And when you go to a practical field, because you require integrated controller with your matrix converter. You cannot keep your controller or like that long wire, many things will be a lot of problem again. So there is a scope, and it need to be designed properly. That is this. In my lab also, they have developed a 100 kilowatt matrix converter. But I am telling previous people they have developed, and they publish it as a 5-6 paper you can find in IEEE Convention. But now new student, I tell you operate one leg. They told, no sir, it is very difficult.
If you are comfortable, if you have any problem,
You can try. If you want to see also in my office, my lab, we have developed, you can 3x5 matrix converter. 3 states.
But whenever I see the converters type of converter, mostly people are discussing the solar, and then there's a DC to DC converter, then AC to AC converter. Like this only most of the people are discussing.
I am showing one converter. It is in this PPT only. That is matrix converter. I'll show you just one. You will appreciate that they with a very hard labor they have developed, and so I'll just show to you this. It is in just in the initial. That converter, the previous PhD students they developed, but
Okay, sir.
these people they cannot even understand. So where is the problem? What is the problem? And they don't run. They are very fearful. They are telling that, sir, it will burn. I told her, even if it will burn, you will run at least one module.
Yeah, sir.
So
Yeah.
like that, I am telling them, I'll show you that you will appreciate that how difficult it is to develop that module. They tested also, they run also once, but all type of moldation technique they could not able to do that one. So this say yes, this is our matrix converter. You can see. 3 into 5 matrix converter.
Okay.
Developed by our own student only.
Okay, sir.
All inverter converter we don't buy, we develop. They develop it. Starting from drilling to PCB design to everything they do. Only switches we buy. So
Okay,
this is your 3.5, 3 into 5 matrix converter. You can do 1 into 5, 1 into 3, and 3 into 3, anything, any thing you can design. So this is complete matrix.
But whenever you see the research paper, in most of the things they will discuss only the inverters and converters only, but very few papers are there only on matrix converters. That's why I'm asking this
because even though they develop very low power. It is 150 kilowatt.
Okay.
Very large, actually, very high power actually.
Okay, sir. Okay.
150.
Okay. Sir. Thank you, sir. Thank you.
Okay.
Are there any questions? Mr. Chala Krishna Rao? Participants, if you have any questions, you can clarify with sir. Sir will be available only for another 5 to 10 minutes. Again, catching sir is very difficult for us.
Okay, thank you. Even sir, if there is no question.
So,
everyone achandi library ga officer.
Officer sir achami. So next, this all 6 days, it will start from 6 and end at 9:30 like that.
Okay.
So, sir, thank you very much for your time.
I should thank you so much
informative.
for inviting me and giving me the chance. And I tell everyone, if you want to see many practical things, you can come to my lab. It is open.
Yes, sir. This time, I think 2 of my students went to your lab for doing internship.
They are working.
Sir, good morning, sir.
Good morning.
Yes, please.
Hello, sir. Good morning.
Yes, please.
Sir, good evening. Sir. Good evening.
Good evening.
Sir, this is Krishna Rao. Hello.
Yes. You please ask your question.
Sir, how to design a inverter for 1 kilowatt system, sir?
How to design?
A inverter for 1 kilowatt system.
Which inverter?
Online inverter, sir, for 1 kilowatt system.
Synchronized inverter.
Online inverter for 1 kilowatt system. There are different design methodologies. Okay. First thing is, what is 1 kilowatt system? You require 230 volt is sufficient.
Single phase 230 volts, sir.
230 volt. So first is bus bar design if you want to more stabilized system. And second one, design of the gate drivers. Third one, this is mean capacitor design. Fourth one is your filter design. Fifth one is
sir.
your isolation transformer design. So these are the few components. Then thermal design, if you are more interested in the understanding the concept, thermal design you can do. And
Sir.
then a complete system, you can then you first you fix your voltage, fix your power rating accordingly, find out what is your DC link capacity. Then other controller, what kind of controller, very low cost controller you can use, some TMS
sir.
controller or something like that. You can one step.
Okay, sir.
First is DC link voltage according to ripple, and then you can find out, then thermal limitation, then you can develop the bus bar, how to connect IGBT to IGBT. That is just,
sir.
those are very, because if your stray inductance is less than 9 nanohenry, then you don't require a snowball circuit for any kind of inverter. So that is very.
Okay, sir. Thank you, sir. Thank you. Thank you, sir.
Any other participant want to ask questions? So sir's email ID, other things are available in IIT Patna website. If you have any query, also you can contact sir anytime. Okay. So thank you very much, sir. Thank you for your very informative presentation. So we'll be in touch always with you, sir.
Thank you, sir.
No, thank you, sir.